Hi, I'm Stu from HiveMind Automation and welcome to the Hive. In this video, we're going to take a look at how to prepare this Raspberry Pi Compute Module 4 for use with my brand new Home Assistant Yellow. Now, fair warning, there's going to be some really advanced concepts in this video. We're going to be using the command line interface on the computer here, and while we're there, we're going to be installing some software, cloning GitHub repositories, compiling these projects, and then running them. Now, I'll be demonstrating these concepts on a Mac. They'll be relatively similar if you're using Linux, but for Windows users, I might need to make a separate video. For now, at least, I'll link to some blog posts with the instructions from other people on the internet. So if you're sticking around to see all of that while I roll the intro, take a moment to subscribe and hit the bell icon to get notified when I release new videos each week. While you're at it, if you like what I do here and you want to help to support the channel, there's affiliate links in the description to a bunch of home automation gadgets that I've reviewed in the past and other ways to support the channel, like supporting the channel directly through my Buy Me a Coffee link. All of those affiliate links and the Buy Me a Coffee link, along with a write-up of this process, will be on my website, hivemindautomation.com.au. With all of that out of the way, let's get started. So in preparation for the arrival of my Home Assistant Yellow, which arrived at the start of March, I ordered some Raspberry Pi compute modules, and to be honest, I had a really hard time getting them in. I'm ashamed to admit that I paid scalper prices for CM4s and they never arrived. Thankfully, I did manage to get my money back thanks to PayPal on that particular transaction, but obviously I still then didn't have any Raspberry Pi compute modules. Now, thankfully, when the compute module part of my Home Assistant Yellow order got cancelled, I did submit an order for some CM4s from a reputable supplier with an Australian presence, and they finally arrived this week. So I'm able to get started on preparing the CM4 to install in the Home Assistant Yellow. I will be talking more about Home Assistant Yellow in the next video, but for this one, we're focusing purely on installing Home Assistant onto the eMMC storage on the CM4 so that the Yellow can actually boot. Now, if you're not familiar with the Raspberry Pi Compute Module 4, it's a more compact version of the Raspberry Pi. It's really designed for industrial applications and embedded applications, and it is a compact form factor with some high-density pins to connect to your different projects. It combines all of the functionality that you have with the regular Pi 4 with the addition of some variants including onboard eMMC storage, which is instead of needing an SD card. Anecdotally at least, eMMC is faster and more reliable than SD storage. Raspberry Pi 4 compute modules also have PCI Express capability as well, and we'll see that a little bit later. So let's take a quick look at the Raspberry Pi compute module that I have here. The first thing I will mention is the size of the compute module. So that is the compute module there, and that is a regular Raspberry Pi 4. So as you can see, the compute module is a lot smaller. It's, what are we looking at? It's around about 56 millimeters long and around 40 millimeters wide there. I've actually seen some I/O boards that allow you to mount them similar to a Raspberry Pi like so. So on the board, we've got our ARM CPU here, there's RAM here, and the eMMC flash here. Now in this case, this is a 16 gigabyte eMMC module. You can get a compute module variant that does not come with the eMMC flash storage built in. Obviously, that means you would need another type of storage to boot off. And these solder pads here are where a Wi-Fi and a Bluetooth module would be if I had one on this module. Unfortunately, the units with Wi-Fi and Bluetooth weren't available, though I do have some more with the Wi-Fi modules on order. So hopefully those will be arriving soon. That said, this is going in the Power over Ethernet version of the Home Assistant Yellow. So it's only the Bluetooth functionality that I'm going to be missing out on. If I flip the CM4 over, you'll see these two really high density connectors here, and that's how you connect the CM4 to Home Assistant Yellow or whatever project you're going to be running the CM4 on. So really, to the core of the problem here, we've got this Raspberry Pi with onboard eMMC storage, but we really don't have any other connections on here for us to be able to flash the memory and install the operating system on it. And it's not like we can remove the eMMC storage like we would be able to with an SD card. And so to facilitate that, I have this Raspberry Pi Compute Module 4 I/O board. It obviously has the mating connectors for the compute module there. And it's got some other really cool things as well. So you can see here that it has a PCI Express port. It's PCI by 1. It's got our 40-pin header for a standard expansion shield or hat that we would get with our normal Raspberry Pis. All sorts of zero insertion force sockets for things like cameras and multiple displays. It's got a slot for a CR2032 battery to power a real-time clock chip that is built into the I/O board. 2 full-size HDMI ports, a full gigabit Ethernet port, 2 USB ports, and we've got a USB slave port. There's an SD card slot here, so if we were using a module that didn't have eMMC, we could actually boot off the SD card. There's a barrel connector here for power and an external PSU connector here and a fan connector here. Now, in order to use this I/O board to flash the Raspberry Pi Compute Module, we're going to need a couple of additional things. First things first, though, I'm going to install the Compute Module onto the board, and it's going to go on like so, and we just kind of line that up and we can push it down. It takes a little bit more force than you might think, and it's a little bit concerning, but once it's in there, it's pretty solidly in there. So that's the CM4 now installed. Now, we also need to install a jumper. You'll see that there's this fixed jumper to disable eMMC boot. So what I'm going to do is put that jumper on there, on the first position of J2. So we're also going to need a way to communicate to the unit. So I'm going to plug in a micro USB connector here to this USB slave. Now, it's important to understand that this port cannot power the Raspberry Pi or any of the I/O board. So we either need to power it using the barrel jack here, the external PSU here, or in my case, I have this Raspberry Pi Power over Ethernet hat that I'm going to install in this position here. I've already got the standoffs for that, so I just need to line everything up and I should just be able to push that down. And now we are ready to go. What should happen if I plug in this PoE enabled Ethernet cable is we should get power, and we do. We've got our red LED there. Now, if you're interested in a much more deep dive of the CM4 I/O board, do let me know in the comments section below and I'll put something together. But now with the Pi installed, the jumper in place, the PoE hat in place, the micro USB cable connected, and the PoE cable installed, it's powered up. But before we can actually get started on flashing it, we need to do a couple of other things. Now, before we can just flash the eMMC storage like we would an SD card, we're going to need to meet some other prerequisites, and they're generally software related. We're going to be working in the command line for a bit here. And if you're uncomfortable with the command line, this process is not for you. We'll be running through this process on a Mac today, but this process is relatively similar for Linux. If you're on Windows, the process is a bit different here, and I'll link to some blog posts for how you can get to the same place. And I may look at doing a video on this for Windows in the future. So to meet the prerequisites, we're going to need to install some stuff. Now, for this to work, you do need to have Homebrew installed before you get started. And this is not the topic of this video, but I'll put a link to the Homebrew site in the video description, and you can find the instructions on how to install it from there. Now, beware, Homebrew does install software onto your Mac from the internet. While it's all free and open source software, there's no guarantees provided for any of it. And if you're running Brew with administrator privileges, you could very easily compromise the security of your device. Use Homebrew at your own risk, and definitely do not try to install it on your work computer. Now, we'll need to use Homebrew to install a tool called libusb, and to do that, we'll type brew install libusb. Now, if you're on Linux, for example, another Raspberry Pi, you would use your package manager like apt, yum, or pacman to install libusb. It is, for all intents and purposes, a USB driver. Now, I've already got libusb installed here. It's not going to show much, but if you're following along at home, yours will look a fair bit different. Once libusb is done, we're also going to need to make sure that we have installed package config. So brew install pkg config, and we'll need to spell that correctly. So again, I've already got pkg config installed, so that is an important thing to note there. I'm going to go to my desktop folder here, and that's just to demonstrate a function a little bit later on. And I need to go over to Microsoft Edge here, and I'm looking for this Raspberry Pi USB boot GitHub library. And this has some instructions here on how to use it on Linux, Cygwin, or WSL, or on macOS. It says to clone the USB boot repository, make sure you've got libusb and package config installed, and it's optional to export the path to include the directory, and then we need to build it. So I'm going to click on this drop down here under code, and I'm going to copy this address here, the HTTPS address, and then I'm going to pop back over to my command line, and I'm going to type in git clone and then type in that address and hit return. And it's cloning into USB boot, and you'll see it's created USB boot on my desktop here, and it's just cloning that down from that GitHub repository. It's worth mentioning that in order to even install Homebrew, but also to use the Git command line options here, you do need the Xcode command line tools, which is very different from the full 14 gigabyte installation of the Xcode IDE, which developers use for creating applications for iOS, iPadOS, and macOS. If you don't already have the Xcode command line tools installed, you can, from a command line, run xcode -select -install, and that will run that. It's giving an error because we've already got them installed here. Now, it's also worth mentioning that if you wanted to, you can just download the zip file from the GitHub repository and unzip that, and that will work just fine as well. You'll note in the GitHub repository that there's this Win32 folder in here, and if you open up that Win32 folder, you'll see that there is this rpiboot setup.exe, and it installs drivers and utilities for programming the eMMC on the Raspberry Pi compute module. For more information, visit the Pi website there. I will take a closer look at that in a different video though. All right, so now that the USB boot repository has been cloned down from GitHub, and you'll see that that is here on my desktop, if I go cd USB boot, and then I can list what's in here, and there's a bit. What we're going to do here is just run make. And what this is going to do is use the make file here which is a set of instructions to build this project. Now, this make command also requires the Xcode command line tools to be installed on your Mac. So I will run that, and that has now built the project. So now that USB boot project is built, I'm just going to list that out, and you'll see here now we've got this Rpi boot that we didn't have before. So that's what the make command actually did for us. So in order to now mount the eMMC storage on our Mac, in order to then be able to image the Home Assistant OS onto the eMMC storage, I'm going to type in /rpi boot and run that. And what should happen now, so now with Rpi boot run, it says the disk you attached was not readable by this computer, which just means that it's detected some storage. And if I open up disk utility and pull that up here, we'll see that we've got this Rpi MSD 001 media. We can just ignore that, but I'm going to open up the Raspberry Pi imager. And what we should be able to do here, if I choose an OS, and we'll just use custom, and I'm looking for HasOS Rpi 4, I'll hit open on that. And then for choose storage, I'm just going to choose this Rpi MSD 001 media. And we should just be able to hit write on this. It says all existing data will be erased. Are you sure? Yes. And it's preparing to write. I need to put in my password and hit OK. And it's now writing to the storage on this Raspberry Pi Compute Module 4. So for whatever reason, it was freezing on 43% when I was using the image that was in my downloads folder, but when I used the Home Assistant OS built into Raspberry Pi Imager, it then proceeded to install just fine. Okay, so it has finished up, it's written to the disk, and macOS has told us that the disk we've attached was not readable by the computer. I'm going to ignore that, and I'm just going to hit continue there. I'll close Raspberry Pi Imager, and over on the B camera here, I'm going to disconnect the power over Ethernet. I'm going to disconnect the jumper that prevents the eMMC boot, and I'm going to disconnect the USB slave port here. And so we should now just be able to plug the power over Ethernet cable back in, and what we should get is the Raspberry Pi booting up, and it looks like it's trying to boot now. I'm getting a flashing LED that suggests that it is booting. I'll give that a moment, and I'm going to start LAN scan over here and see if we can find another Raspberry Pi on this network. There we go. So we've got a home assistant.local. I'm going to copy the IP address here now that it's showing up in LAN scan. Head over to Edge, and I should be able to now paste that address in, hit return. It's refusing to connect at the moment. What I might do is put 8123 in there, and there we go. So we've got Home Assistant preparing. So we now have Home Assistant running on this Raspberry Pi Compute Module 4. So that's imaging the eMMC storage on a Raspberry Pi Compute Module 4 from a Mac, and it's pretty similar on Linux. If you're comfortable with some developer tools in the command line, you're not going to have too much trouble here. But if you're inexperienced, I can appreciate that you will get overwhelmed pretty quickly with this process. If you're on Windows, check out the description, and I'll put some links to resources in there where you can find the instructions. If I haven't had a chance to make a Windows video by the time you watch this, there will at least be a link to a blog post from someone who's written it up better than I ever could, but I will work on a Windows version for you. I will say that this process is far from accessible for all skill levels, so if any of what I've spoken about here isn't making any sense, then this process probably isn't for you. In researching this video, I found that there is a far simpler way to prepare the Compute Module 4 to work with the Home Assistant Yellow, and it doesn't matter whether you're on Mac, Windows, or Linux for that easier method. So I'll cover off that method in a future video. In the very next video though, we're going to finally take a look at the Home Assistant Yellow. That's all we have for this video, and I do hope that it helped you in your home automation journey. Be sure to comment down below with a home automation idea you'd like to see me cover in a future video. And don't forget to follow HiveMind Automation on Twitter, Instagram, and Facebook. If you like this video, hit the thumbs up button down below to give it a like, and if you're not already subscribed, now's a great time to consider changing that. While you're at it, if you hit the bell icon, you'll get a notification when I release new videos each week. And if you like what I'm doing here and you want help to support the channel, there's a bunch of ways that you can do that, including my Buy Me a Coffee link in the video description. All of those affiliate links and the Buy Me a Coffee link are also available on my website, www.hivemindautomation.com.au, where I'll also put a write-up of this process. Thanks very much for watching. I'm Stu from HiveMind Automation, and I'm looking forward to seeing you next time. Bye for now.